All right, yet another calculus video. I've been doing calculus for some time now, following James Stewart's 6th edition. By the way, this is also in his Essential Calculus, Chapter 6. Okay, so we've been doing strategies for trigonometric integrals. So 8.2a was about strategies for integrating combinations of powers of sine and cosine, where at least one of them is odd. And what we did is we pulled the odd out to make it even. So like if you had a sine to the third power of x, we pulled one of the sines out, and then we converted the remaining sines into cosine, and then we use substitution, u equals cosine. All right, so that was 8.2a. 8.2b was strategies for integrating powers of sine and cosine where they're all even. And what you used in that case are the half-angle identities. I won't remind you what they are. See the previous video. The half-angle identities allow us to beat down the power until we get down to the first power of just sine x, cosine x. And once we've beaten it all out, we bing, 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 we're making tenderloin. Once you've beaten it all out to the first power, then it's fairly easy to solve. This video is about strategies for integrating powers of tangent and secant when secant is to an even power. And our basic strategy is going to be to pull a secant squared x out, convert the rest to all tangent, and then substitute u equals tangent. All right? If that didn't immediately click, hold on, we'll get there. But first, what are the trigonometric formulas that we need to know, especially in this? Well, you remember in the first two videos, sine squared x plus cosine squared x equals 1. Well, the key formula to remember, one of the key formulas to remember for this one, is that secant squared x equals 1 plus the tangent squared x. This is one you should memorize. The other form of it is, tangent squared x equals secant squared minus 1. It doesn't exactly work, but you might, if you watch the previous video, I thought cosine's strong, because on the half-angle identities, the cosine does the plus. So I've done that to help me remember, again, whether it works or not, doesn't matter, it helps me remember, that secant is strong. It's 1 over cosine, right? Secant is strong, so the secant is the one with the plus. That's how I remember this. And then, of course, you can easily solve this. If you remember one of them, you can get the other one. There's one other thing you need to remember, and that is that the derivative of the tangent of x is the secant squared x. The derivative of the tangent of x is secant squared x. So if you don't have these three the trig identities and the differentiation of tangent here, if you don't have those firmly in mind, let's pause for a moment and let the sun burn us with its rays of knowledge, okay? We're going to have an intense sun memory moment. You got it? You memorize it? Okay. Now, let's do an example. This is from the book. It works well. So you can see that we have tangent and secant here, and they're both to even powers. That's what this video is about. So we're going to pull a secant squared x out from there, which is very easy to do, right? Because secant squared times secant squared is secant to the fourth. All right, so we've done, check, step number 1. We pulled a secant squared x. So now what we want to do is we want to convert all the others to tangent. So remember what secant squared x is? Secant squared x is 1 plus tangent squared x. Yes. So there's the formula. We just saw it. Secant squared x equals 1 plus tangent squared x, right? So we substitute that in, and we've got tangent squared x equals 1 plus tangent squared x times secant squared x. All right. Now, we're going to substitute with u equals tangent of x. Again, we've got the whole process right in front of us. If secant is to an even power, pull a secant squared x out, then convert the rest to all tangents using this identity. All right, and now we're going to substitute u equals tangent x. So if u equals tangent x, then we know from the previous slide that du is going to be secant squared x. And for you math majors out there, I know it should be dx. I spaced it. I'm sorry, I spaced it. It's du equals secant squared x dx. I'm sorry. I'm not going to go back and pause the tape at this point. All right, so now we're going to get what? U to the 6, right? Times 1 plus u to the second. And then this is du, secant squared x dx. I should have had a dx there. I feel bad. All right. So, okay. So now this is very manageable. This is very manageable. We can go ahead and multiply it out, right? Multiply it out. There's what we had on the previous slide. 6 plus times 1 is u to the 6th, and u to the 6th times u to the 2nd is u to the 8th, all right? And then these are very easy integration things, right? Very easy. 1/7 u to the 7th. Does it go backwards? Yes. 7 times 1/7 cancels out. Minus 1 is u to the 6th. Bing. 1/9 u to the 9th. 9 times 1/9 is 1. And then minus 1 is 8, u to the 8th. Ding. Plus a constant. Yay. Now all we have to do is substitute tangent back in. There's your answer. 1/7 tangent to the 7th of x plus 1/9 tangent to the 9th of x plus c. And quod erat demonstrandum. We have done it.